My dear students, in the previous lecture we had discussed about two physical quantities, that is distance and displacement. In case of distance, if you remember, I had told you, suppose object moves from A to B along two different paths. Then the path length, suppose this is P1 path and this is P2 path, right? Then P1 and P2, the length of these two paths are called distance, and the shortest path which gives the displacement. The distance between the two positions of an object along the shortest path is called the displacement. So distance and displacement is clear. So distance is a scalar quantity and displacement is a vector quantity. So scalar and vector, these things we will discuss later, and I will make a separate video for that. And one thing should be understood well, that displacement tells the magnitude as well as direction, whereas distance tells only the magnitude. So those physical quantities which are having magnitude as well as direction are called vector quantities. So displacement is a vector quantity and distance is a scalar quantity. So you write distance, it is a scalar quantity, and displacement, it is a vector quantity. Since we are dealing the motion of an object along a straight line, so in this case, by the example we will understand. Suppose from this point O along this line, object is moving. Suppose initial position over here, this is P1, then it reaches up to P2. Motion is along this. From O, this is the reference point about which I have already discussed with you. From here all the measurements are done. So it reaches from O to P1 and then up to P2. So from O to P2, what is the distance? This length. This is the distance, because this path is being followed by the object. Then what is displacement? Here displacement also be the same, just because it is a straight line. So in this case, when the motion is along the straight line and there is no reversal, when the motion is not getting reversed, in that case displacement and distance moved by the object will be same. From here to here, path followed is OP2 and displacement is also along this. So object moves from O to P2, the distance and displacement will be same because the straight line motion. So we can write, in case of motion of an object along a straight line, without reversing the direction of motion, the distance will be equal to the magnitude of the displacement. It is very important. I have mentioned the word magnitude of the displacement. Why did I write magnitude of the displacement? Because displacement is a vector quantity. As I said, vector means it has got magnitude as well as direction. From O to P2, certain direction is there for displacement. Here from A to B, when displacement we are measuring means along this line only has to go. But for path, length of path, directions are here, direction was this, here. For this path, this was the direction. So for distance, direction is always changing at various points between A to B. As far as paths are concerned, directions are changing. But in case of displacement, this length is called the distance, but this length is called the displacement. For displacement, direction is fixed. In a particular direction one has to go. That is why displacement is a vector. So here two things are there, magnitude as well as direction. So here we are talking about the magnitude of displacement when the object is moving along a straight line and there is no reversal of the motion. Means motion is along this line only. It is not getting reversed. So at any position, distance and displacement will be equal as far as the magnitude of the displacement is concerned. So therefore, in this case, for the straight line motion, distance is equal to magnitude of displacement. Two vertical lines I have drawn. In between displacement is written. Two vertical line tells modulus or mod of displacement, because displacement is a vector quantity. We are taking magnitude. In this case, distance will be equal to magnitude of displacement. So this is very much clear. So now, under what condition, that too should be known. Means displacement is equal to this, or distance is always greater than the magnitude of displacement in this case, because length of path, the displacement, the magnitude is the shortest distance. Since it is the shortest, so rest of the lengths will be definitely more than this shortest path. It means distance will always be greater or equal to the magnitude of displacement in general. So we can write, in general, distance is greater or equal to magnitude of displacement. It is always greater in this case. In this case, when there is straight line motion, this is equal. So in general, taking this and this together, we will write this definition about the distance and displacement. Of course, the magnitude of displacement. So now we are going to discuss other physical quantities related to motion is speed and velocity. Now we will discuss the average velocity and average speed. So what is average velocity? We have already discussed distance and displacement. So average velocity is defined as, average velocity is the change in displacement with respect to time is called average velocity. Means what? Suppose object starts moving from here, O, moves along a straight line. It reaches over here at P1 and this distance is x1. Then it reaches to P2. This is x2. And from here to here, time taken is t1, and from here to here, time taken is t2. So From O, displacement over here is x1, time taken is t1. From O, displacement is x2, time taken is t2. Therefore, change in displacement is equal to x2 minus x1. From here to here, object has moved from here to here. This displacement is x1 and this is x2 from here. So from P1 to P2, it has displacement is x2 minus x1. That is from P1 to P2. And time taken is equal to T2 minus T1. This is displacement and this is the time taken. So displacement is known from P1 to P2 and time taken is known. Therefore, average velocity is equal to x2 minus x1 upon t2 minus t1, and average denoted by v bar, that is x2 minus x1 upon t2 minus t1, and it is denoted by delta x upon delta t. So v bar, average velocity, is equal to delta x upon delta t. This is the average velocity. So concept of average velocity is clear, and I am taking the object moving from P1 to P2, but reference point is this, reference point. All the measurements are done from O. So from here to here, displacement is x1, and from here to here again it is x2. So change in displacement from P1 to P2 is x2 minus x1, and rest of the things I have mentioned earlier. So this is called the average velocity. So in case of linear motion along a straight line, so direction is simply by plus or minus, we can say. So in this direction, suppose it is moving, then it is called positive. In the reverse direction, it is negative. So direction can be specified by plus or minus. Reason is because it is along a straight line. So in this direction, if you select as positive, the reverse direction will be negative. So this is the velocity we have found. So now we will go for average speed. In general, average speed is the total path length, the actual path length. Actual means the object has moved along that path. Path length per unit time by the object. So we can say that in this case v bar magnitude we have taken on a total path length upon total time taken. This is the average speed. Average speed, the total path for the same duration. For the same duration, suppose from A to B, object is moving along this, and this displacement is this. This length, suppose it is S, and time taken is T. So we will say average speed is equal to S by T. But average velocity, suppose it is S1, this length, so average velocity is equal to S1 by T, because from here to here time taken is t. So it is s by t and this is s1 by t. Since s is more than s1, then average speed is greater than average velocity. But in the linear motion, average speed may and may not be equal to the average velocity. It depends on the displacement. If reversal is not there, then the average speed will be equal to average velocity. Now, when object is moving and we are finding average speed and average velocity, average means during motion from A to B. Average means if a constant velocity is being given, so same time will take from A to B. That is called the average. In between A to B, this point A, this is B. Object is moving. So in between these two positions, at this point, at this point, at this point, velocities may be different. V1 is V2 and V3. But from here to here, displacement is taken and total time is taken. If we divide, then we are getting average. Means that implies that a constant velocity by which if it is it moves, object moves from A to B, then it will take same time. So here suppose from A to B takes time t and displacement is d. So V bar average velocity is d by t. Means this d by t average velocity means with this constant velocity if it moves, it will take t time. In between, even the velocities are changing at different instants. Velocities are different, but average velocity if you find, then with that constant velocity it moves from A to B, it takes time t. Even though velocity is various positions, suppose it is A1, A2, A3, velocities are different, isn't it? So finding the velocity at a particular instant, the velocity at particular time is called the instantaneous velocity. So how will you find? Another term is there, that is instantaneous velocity. Instantaneous velocity. What is instantaneous velocity? Velocity of an object. The velocity of a moving object at particular instant is called instantaneous velocity. So instantaneous velocity is clear, because in 5th second, 7th second, 9th second, suppose it takes 50 seconds. So 1st, 2nd, 5th, 9th, at that particular instant, whatever is the velocity is called the instantaneous velocity. So how the instantaneous velocity is being defined mathematically? We know that average velocity V bar is delta x upon delta t. This delta tells the change. Delta x tells the change in displacement and this is change in time. Instantaneous velocity or simply velocity. Instantaneous velocity is denoted by instantaneous velocity denoted by V is limit delta t tends to 0 delta x upon delta t. Means the duration, particular instant we want. So this change is not much. It is brought to very close to 0, then at that moment, whatever is the velocity is called the instantaneous velocity. And this is equal to, it is new notation is given, dx by dt. Therefore, v is equal to dx upon dt, and dx by dt is called the instantaneous velocity. It is very important, and this will be used very frequently at most of the places, and you should remember this. So whenever we talk about the velocity of a car or train or anything, so we are talking about the instantaneous velocity. Odometer of your car, what kind of velocity it gives at a particular 60 kilometers per hour. What is the 60 kilometers per hour? At that particular instant, its velocity is 60 kilometers per hour. It is an instantaneous velocity, simply the velocity of the object or of that car. So we will deal with what is the geometrical interpretation of this instantaneous velocity. So we have discussed about instantaneous velocity. I will tell you what is the geometrically it is being interpreted. Suppose we have plotted the displacement time graph in this direction, that is displacement, and in this direction we have taken time. Displacement denoted by x and this is denoted by time, right? It is origin 0. Now suppose we plot the graph, and graph is something like this. At different instants, different displacements. So this kind of graph we are getting. Suppose a particular instant at this time t2, I want the speed. Means, of course, it is velocity by magnitude we are talking about. So at this point, suppose this point is A, this point is B, and here it is time t1. Certain velocity is this. Suppose it is x1 and this is x2, it is t1 and it is t2. So displacement time graph is this. So what is this significance of x2 minus x1 upon t2 minus t1? We know that average velocity is x2 minus x1 upon t2 minus t1. So here if you join A and B, and if you join this, let this point be C. It is x1 and this is x2, so this part is x2 minus x1 and this is t2 minus t1, right? And AB is the chord. AB is the chord on this graph, right? We can say that graph of displacement and time, a motion of an object. So x2 minus x1 upon t2 minus t1 means if we consider this angle as theta, then tan theta is equal to x2 minus x1 upon t2 minus t1. So x2 minus x1 upon t2 minus t1 gives the tangent of this angle, and tangent of this angle means slope of the chord. So this is what it is, slope of the chord AB is equal to tan theta, that is equal to x2 minus x1 upon t2 minus t1. It means average velocity between B and C. Average velocity, this is average velocity. Average velocity between A and B is slope of the chord, right? Now, if B approaches to A, we want instantaneous velocity at this point. Means this delta t, this is delta t, this is delta x. So this is equal to delta x upon delta t. So delta t should be approaching to 0 means B should approach to A. As B approaches to A, delta t approaches to 0. Graduality is coming over here. So when B reaches to A, this chord AB becomes tangent at this point, right? And this is theta 1. Means when delta t approaches to 0, B approaches to A, and then the chord becomes tangent at A. B approaches to A, then this chord becomes tangent, and the slope of the tangent at A is equal to tan theta 1, because tangent makes angle theta 1 with this, so tan theta 1, that is equal to instantaneous velocity. Velocity at A. So concept of instantaneous velocity is clear from this. Means at any point, if tangent is drawn on the graph, then the slope of the tangent tells the instantaneous velocity at that point. Now I will talk about another physical quantity, that is acceleration. What is acceleration of a moving object? The rate of change of velocity of an object, of course moving object, is called acceleration. As velocity is a vector quantity, so the acceleration is also a vector quantity. And displacement, velocity and all these physical quantities are vector quantities. So it is denoted by A, suppose average acceleration, then it is delta V upon delta T. And instantaneous acceleration is called limit delta T tends to 0, delta V upon delta T, that is equal to dV upon dt. So A is equal to dV upon dt, that is called the instantaneous acceleration of the moving object, right? And this is instantaneous, this is the average, because delta here and dV by dt, the moment I do delta t tends to 0, approaches to 0, in that case it is instantaneous acceleration, that is dV by dt. So through various graphs we will understand the different situations of the moving object. First we will consider, suppose it is displacement time graph. It is, suppose here we will write displacement as x and this is t. If a straight line parallel to time axis, what does it imply? By with the time, as the time changes, its displacement is not changing. Means this implies the body is at rest, because displacement is not changing. Here another graph we will draw. It is x and this is t. Here this is the graph. Here this tells at every point, if you talk about the slope is constant. Slope is constant, and just before this we will understood the slope of the graph or tangent at any point tells the velocity at that point, means instantaneous velocity. Here, since it is a straight line and it is not parallel to t, it means it is constant velocity. This implies velocity is constant. This is x, of course it is displacement, this is time. Graph is like this. At any point if you look at, if I draw a tangent at this point, this is a tangent at this point, this is a tangent at this point, this is the tangent, so it is A, B, C. This is theta 1, this is theta 2, this is theta 3. So what is the instantaneous velocity as A? So velocity at A is equal to tan theta 1, velocity at B is equal to tan theta 2, velocity at C is equal to tan theta 3, right? And theta 1 is less than theta 2, less than theta 3. Therefore, tan theta 1 is less than tan theta 2, less than tan theta 3, and therefore, right, VA is less than VB is less than VC. It means velocity is changing, right? So this is variable velocity, the graph of variable velocity, implies the graph of variable velocity. These are very important things. By observing the graph, analyze the graph and draw the conclusion. What kind of motion is this? So variable velocity, it is called non-uniform velocity also. Constant velocity means it is called uniform motion. It is called uniform motion. Means velocity is constant, and it is non-uniform motion or non-uniform velocity. Motion uniform means velocity is constant. Non-uniform motion means velocity is varying, right? So these are the simple graph of displacement and time. Now, if the displacement time graph is of this kind, so we will take 2-3 points on this. This is point A, this is point B, and this is point C. In previous graph was like this, where the velocity was increasing. So it is varying velocity but increasing velocity. In this case, see, if you draw the tangent on this, suppose theta 1 tangent on this, this is theta 1, this is theta 2 or A, and theta B, and on this if you draw the tangent, that is theta C. So velocity at A is tan theta 1, so VA is equal to tan theta A, VB is equal to tan theta B, VC is equal to tan theta C, right? And we can observe that theta 1 is greater than theta A is greater than theta B greater than theta C. Therefore, tan theta A is greater than tan theta B greater than tan theta C. So this implies VA is greater than VB greater than VC. Means, as this graph tells that velocity is gradually decreasing, right? So the velocity, this implies velocity of the moving object is decreasing with increase in time. So various graphs of displacement time, we can draw different conclusion, and some of them I have narrated, and I hope it is clear to all of you, and I will discuss something different and more later.